Hello, Speculator here from the Lockpicking subreddit. I was recently asked on one of the threads about how to decode one of these combination locks. There's a lot of really good videos out there, but I feel like some of them get convoluted and lost in the math. So this is supposed to be purely practical, and if you want to know the inner workings of why it works, go watch the explanation video that Sammy Kamkar has on YouTube. So what we can find out from mechanically manipulating this lock is three numbers. The first number is a sticky number, and then you get two numbers for a possibility of the third digit of the combination. So the first digit, second digit, third digit. I call the second digit the guess. This one's a sticky, and this is one of two, and I'll show you all why. The first one is the most important and usually the most difficult, most error-prone number. The sticky number is where you pull the shackle all the way up till it seizes, and you can't move the lock. Then you let it off just a millimeter and kind of pinch it with your fingers. And then once it can rotate, you spin until you find a sticking point. So I'm finding sticking at 10. So it might be 10. It's not always the first sticky number. You'll get a lot of false positives on this, which is why it's very important for reproducibility. Spin it around randomly, seize at a point, and go again. Okay, at 25. Yeah, definitely started at 25. So 10 and 25, and it's only going to be one. So what I'm going to do, I have two possibilities now. So I'm not looking, obviously on the camera you can see what I'm doing, but I can't. And spin it around. Now I'm not looking at it and I'm rotating. I feel a strong resistance here. Okay, so this is giving me a lot of confidence in 25. I'll probably do it one more time. I'll just spin randomly. I'm not looking, I promise. And off we go. I'm just rotating. I feel strong resistance. Yeah, definitely. Okay, bam, 25. 25 is our sticky number. And that's actually related to the mechanical distance between the correct combination by a certain number of millimeters on the circumference of this dial. So to find the correct number, you add 5. Now that's not always true, and there's different tolerances built into different locks depending on when they're built. So sometimes it's actually 6. And even in rare cases, 4. But generally 5 or 6 will get you the correct number. And that's the only one that really messes you up and causes you to lose a lot of time on this trick. The next two numbers you get are two numbers between 0 and 9. So what you're looking for is something where it doesn't go from a whole number to a whole number. Now here it's really tricky. It looks like it's going from 1 to 2, but it's really going from like 0.9 to 1.8. So actually 1 is our number of interest, 1. And then you keep this, you allow it to rotate, and I'm pulling up with this finger on the shackle. Okay, there's a good example. That clearly goes from whole number 5 to whole number 4. Whole number 5, whole number 4. Okay, that's passing over 8. So I know 8 is our other number of interest. And they're always being odd and an even number. Well, I say always. In my experience, it's always been an odd and an even number. And so now this is the only information we can get from mechanically manipulating. The rest of it is math and related to how these dials work. You can imagine inside here, I'm drawing these different sizes, but they're all the same size in real life. You have dial 1 in the center, and it's got 4 little knobs on it. And these knobs manipulate the knobs of the second dial. And then on the third dial, the knobs are in the same orientation with the same set of 4 as the first one, and they manipulate each other. What that means is that if you divide the first digit, 30, by 4, this remainder, whatever remains after this, which is 2, remainder 4. Divide by 4 and the remainder is 2, we'll have the same remainder down here. What these numbers tell us is that you have 40 digits and they're divided by 4. So you add 10 to each of these, 11, 21, 31. There's no 41. And 8, 18, 28, 38. The 40 divided by 4 gives us 10, so you can add 10 to this, and it will be one of these 8 numbers. But we know that it has the same remainder as the first number, which is 2, so it can't be any of the odd numbers. 8 divided by 4 is, remainder 0 evenly. So it's 18 and 38. Right, because it divided up by 4, you're no remainder, 18 and 38. Now to find out which one's correct, and I lied to you because earlier I said that you can't find more information, you can't find more numbers, but we can find the correct number here. You go to 18 and check for slackness. Now I know from experience it feels pretty loose. Go to 38, much tighter. So I'm going to say pretty confidently our correct number is probably 18. No relation to 1 and 8, that's pure coincidence. So we have 18 and 30. Now the second number I say is a guess. Now you look at these notches here, which I didn't do the best job drawing. They're offset from the center one by a factor of the distance between these notches built into the dials, which so happens to be this remainder 2, which we also have here, remainder 2, you add 2 to that number. So if the remainder is equal to 2, this remainder equal to 2, horrible mathematic notation, add 2. So we start with 4. Now, what this will tell us are 5 possible positions around the dial. If you divide 40 by 5, you can add 8 to that. So the 5 possible positions we're looking at are 12, 20, 28, 36, where we could get the possible correct number because it has a correct remainder of 0. And we also have to go up by add 4 because there are 10 total positions around the dial. And so we add 4 to this first remainder. Does that give us 8, 16, 24, 32, and 0, right? Now the last trick that we can do is that the second number and the third number cannot be closer than 2 together because you remember we added 2 to this remainder to get to the second number. So they can't be within 2, or these notches here won't actually manipulate each other to get into the correct position. So 18 allows us to get rid of 16, and 20 plus 2 minus 2. So that leaves us with just 8 numbers we have to brute force. So to show you how to do this, I'm sure everybody knows how to do a lock, but just for cursory reminder, you go to the first number, and we're going to try 4. So 30, you pass 4 once, you always pass the second number once, and come to 4, back to 18. Now this video is already longer than I want it to be, so I'm going to speed up the process here, but that's how you do it. And it's always right, left, right, and I remember that by Real Lizards Roar. And I picture the little Jurassic Park lizard spitting in the fat guy's eyes. That's how I remember it. If you can remember it just off the top of your head, good for you. I can't. So let's go to the next one. So we're going to go 30. And if you hear heavy panting, it's not me. It's my fat dog. He's, anyway, 30. Pass 12 once. 12. And we're at 18. That opens the lock. Now, Stab in the Eye on the subreddit said that I should use a lock that I can prove to be random. I'll do that in the next video. This is an explanatory video. And just to be upfront with you, I did test this lock to make sure it works, but I did buy some locks that I don't know if they do work from a lot online. And so in the next video, I will do a speed run, quote unquote, on those. And try to show you that this really does work, and I've done it on about a dozen locks at this point, and I love doing it. Any questions, speculator on this lockpicking subreddit, or you can just message me on YouTube. All right, have a great day.